Okay, so today we're talking about shapes of distributions. We kind of talked about this a little bit before, but when we're talking about shapes, it is the way data values are clustered. And it's important to notice the shape of the distribution. So we've looked at it before with a box and whisker plot. Today we're looking at it with bar graphs. So when it's like this part right here is considered my tail. So only the two on the ends have tails. Otherwise, it's symmetric. So this one on the left is skewed left. The tail on the graph extends to the left side. And most of my data is on the right side. That's where my taller bars are. So when it's symmetric, the data on the left side mirrors the data on the right. And this is called a bell-shaped curve. Because if I went to outline the shape, it kind of follows a bell pattern. This is also called a normal distribution. Okay, so when it's skewed right, the tail on the graph extends to the right side. And most of my data here is on the left. Okay, so we can use the shape of the distribution to decide the appropriate measure of center, so that is choosing between mean or median, and then the best measure of variation to describe the data set, which is choosing between a 5-number summary or standard deviation. So first I'm going to take a look at these two graphs. This one is left skew, and this one is right skew, because of where the tails are. So on the left one, this first dashed line represents my mean. And the second dashed line represents my median. On my right skew, the first dashed line is also my median. And the second dashed line is my mean. So which of those looks like it better represents half of the data, the mean or the median on those two graphs? It's actually my median because it splits up my numbers more equally there. Because I want to have about half the numbers on one side and half on the other. So when my data distribution is skewed, my measure of center that I want to use is my median. Okay, and then my measure of variation is going to be my 5-number summary. That just always goes together with the median. Yeah. It has 3 bars on each side, but the bars are the total number of numbers. So like the higher the bar is, the more numbers there are in each bar. Okay. So then when my data distribution is symmetric, this is where it looks the same on both sides. This one, my mean is right there in the middle. So this is my best measure of center. And the measure of variation I want to use here is my standard deviation. Okay, so here we have a box and whisker plot from the ages of the backpacking expeditions in the mountains that we did in our 11.2 notes. Notice how my left whisker is longer. So, in the box and whisker plots, the whiskers would be classified as my tails of the data. Okay, so on this one, since our left whisker is longer, we know that this data is skewed which way? Which one is it, right or left? Which one is longer? Okay. This means most of our data lies on the right. So for this one, my best measure of center, which would be the median, which is this middle line right here. What is my value at the median? So B wants me to make a box and whisker plot that represents the data and describe the distribution of the data if the data is skewed. And it gives me some values. I can do this by hand, or I can also do it by using the calculator to get my values. Which way would you prefer me to use? By hand or using the calculator? You want me to do it by hand? Okay. I'm going to write them all in one line. So I have, in order, I have 0, 2, oh wait, I had 2 zeros, right? And then I have 2 2s. And then I have 5, 7, 9, and 12. Okay, so the first thing I want to find out is my median. To find that, I want the number in the middle. But I am between two numbers, 2 and 5. So how do I find the median then? Huh? I do have to divide, but what do I have to do first before I divide? Add them. So I'm going to do 2 plus 5, and then divide by 2. What's 2 plus 5? 2 plus 5 is 7, and then my final answer is 3.5. So because 3.5 is not actually a number on this number line, I'm going to draw a line and write 3.5 to show that's where my median is in the middle of those. So to find my first quartile, I want to look at the middle of all of the numbers to the left of my median. So I'm looking at all of the numbers left of 3.5. There's 4 numbers I'm looking at. So when I look at this, my Q1 is in between 0 and 2. How do I find that? Add them together and divide by 2. So I have 2 divided by 2, or 1. Okay, so same idea for my third quartile. I want to look at everything to the right of my median. Since my median wasn't a real number, I look at all 4 numbers to the right side of that. This one is going to be between 7 and 9. So that gives me 16 divided by 2, or 8. Okay, so what's my minimum value? Yeah, Zeke?
0.
And then my max? 12. So I want to go ahead and put this on a number line. First thing I'm going to do is I'm going to start off by numbering my number line so I know where to put my numbers. Then for all 5 of those values I have right here, I'm going to draw a line. So 3.5 is in between 3 and 4. Okay. Then I'm going to connect my 3 middle lines and make a rectangle or a box. And then from my box, I'm going to draw a line to the ends to make it look like a whisker. Okay, so I'm also going to go ahead and show you this on the calculator. So what I would do if I wanted to do this on a calculator is I go Stat, and then I go Edit. If I want to get rid of numbers that are already, ooh, that looks terrible. If I want to get rid of numbers that are already there, I arrow up to L1, and I want to make sure I press clear and arrow down. If I press delete, it will get rid of my row, and it will mess up my numbers when I go to do it. So then I want to type in the numbers. So that was 0, 7, 2, 5. If I'm typing in the calculator, it doesn't need to be in order. The calculator will figure that out for me. So once I type in all of my numbers, I want to go second mode to go back home. I press Stat, I go Calc, and then I want to do the one variable statistics. So we've done this before. If I go down to Calculate, if I notice down here it says min x is 0, Q1 is 1. Then if I keep scrolling, it tells me my median is 3.5, my third quartile is 8, and my max is 12. So the calculator can also give me the 5-number summary as well, if you're not confident in finding those values. Okay. So which whisker is longer, my right or my left? Yeah? My right. So which skew is this, left or right? Right? So most of my data is on the most of the data is always opposite my skew, so it's on the left. So my best measure of center for this would be my median, and the median was what? 3.5. Okay. Okay, does anyone want to share what they got for their minimum value? No, there's a smaller number. 12. And then my Q1. 16.5. My median. My third quartile. 29. And then my max. 35. So for this one, when I go ahead and go to make my box and whisker plot, I'm going to count by 2 so I can get everything on the number line. I'm going to start at I'll start at 10. Okay, so then I want to go ahead and draw my lines. So 12 is really easy. 16.5 is going to be a lot closer to 16 than it is 18, but it's not going to be on 16. Then I have 22. 29 is in between 28 and 30. And then 35 is in between 34 and 36. Okay, so then I'm going to connect my middle ones to make my box. Then I'm going to go to the end to make my whiskers. So which whisker is longer? My left or right? Right? So that means my data is skewed, right? And most of my data is on the left. So what's the best measure of center here? 22, and that was the median. Guys, stop talking. Okay. So then a symmetrical bell-shaped curve is defined by the mean, which is denoted by this symbol. I don't know if I've talked about this one's name. This one is called mu. And then we've talked about this one. This one's called sigma. Is the standard deviation. So okay. So the area under the curve represents the probability with the total area equal to 1. So probability is just percent possibility of the number being in there. Okay. So there's something called the empirical rule. This states that approximately 68.2% of the data is within 1 standard deviation of the mean. So that means adding sigma or subtracting sigma from the mean, one on each side, will get us about 68% of our data. Then 95.4% of the data is within 2 standard deviations, so most of the data falls within 2 either way. And then our final part is approximately 99.8% is within 3 standard deviations. So then what I'm going to do is on this one, I'm going to fill in. So if I'm looking at just this half, if each between these 2 points is 68.2%, then in the one half is 34.1%. And then this side is also going to be 34.1% because that's the other half. Okay. Over here, this is going to be 13.6%. And this one's also going to be 13.6%. So if I add up all 4 of the percents I have, these should add up to 95.4. This one is 2.2%. And then my very last spot is going to be 0.1%. Sorry, I got the decimal wrong spot. Okay, so this wants me to draw and label my normal distribution curves and then answer my questions. So number 1 says the weights of 50 football players are normally distributed with a mean of 178 pounds and a standard deviation of 8. So this 178 is going to go in the middle. And then because it says my standard deviation is by 8, each dashed line I'm going to count by 8. So this one I'm going to add 8. So 178 plus 8 is 186. 186 plus 8 is 194. And then 194 plus 8 is Then I want to fill in my numbers on the left side. I'm going to start subtracting 8 because left side gets smaller. So 178 minus 8 is 170 minus 8 is, and then 162 minus 8 is 'So A wants me to find what percent of players are between 178 and 194 pounds. So I am looking at these two sections. So going off of my percents from up above, I want to add the percents for those two sections together. What percents am I adding together? If it helps, I can copy them back down on this one. Yeah, Zeke, which ones am I adding? 47.7%. Yeah, that's my final answer. So I'm adding the 34.1 and the 13.6. Should give me 47.7. So 47.7% of the football players are within that weight range. Okay. B says, what's the probability that a player weighs at most 170 pounds? So this means add up all the percents to 170. So that's going to be those three bars. I want to add the percents together. So I'm adding 0.1, 2.2, and 13.6. Yeah? Mm-hmm. Okay, so C wants me to do less than 162, so that's everything left of 162. And then more than 194. So everything I just highlighted in purple, which is 0.1 plus 2.2 plus 2.2 plus 0.1. Okay, and then my last one for this question is how many players weigh between 170 and 186? So that is those. And because I'm actually talking about players, I'm going to multiply this by 50, and I'm going to turn my percents into decimals. So I'm going to have 0.341 plus 0.341. So I'm going to have 50 times what is 0.341 plus 0.341. .682. And then 50 times 0.682 is? No, it should be 0.682. I think you switched your numbers when you typed it in. It's 0.341. So 50 times 0.682? Yeah. 34.1. So we are talking about actual people. Does that make sense to say 34.1 people?
No.
So what should I do?
Round.
To
Round.
nearest whole number, because this is already at a tenth. So what's my nearest whole number here? 34.
You are 1/10 of the person.